and welcome to the Beginner's Scratch Programming Workshop. My name is Dan. This program is aimed at very low-level users who are perhaps new to Scratch or to coding in general. If you've been watching any of our other educational videos, you may have seen Jason coding on the BBC Micro. One of the videos features him making a game where you chase an object around on a screen and getting points when you catch it. This is a fairly simple game, but there were dozens of lines of code and it took quite a bit of knowledge to make it happen on 1981 technology. Fast forward 40 years and we can do the same thing in a few minutes without writing a single line of code. Scratch is one of the many ways to communicate with the computer and have it do things we want it to do. It breaks down coding into chunks which you can link together like Lego to make programs, games, or animations. It turns coding into a tactile and fun experience. Even if you have no experience with coding, you can jump right in and start making fun projects with ease. It has its limitations, but it can run real-world objects like buggies, and it can also run off a Raspberry Pi or a microbit. Scratch can be used entirely online, or you can download it and use it like an app. It can be found at scratch.mit.edu. Links on the screen and in the description below. When you are on the site, go to Create at the top and you can see our workspace. On the far left, we have the coding blocks we will be manipulating to run our programs. We'll go through these as we progress through the program. The big space in the middle is where you put the blocks. To the right, we have the program window. This is where you can see your program running. The window measures 480 by 360 pixels, with 0 in the middle, minus 240 to the left, plus 240 to the right, and so on. Below this is the sprite window. A sprite is a pixel-based image we will be using in games. If you've played the old Mario and Sonic games, these are sprites. These days we mostly have 3D polygon-based characters, but many modern games still use sprites. Between the program window and the sprite window, we have the sprite properties section. Here we can change the name, the X or horizontal position, the Y or vertical position, the size, and the direction the character is facing. If we type a number into the X or Y blocks, we can teleport our sprite to those coordinates. For example, I've added the positive number, so it's gone 100 pixels to the right. If I put in a negative number, he'll go all the way to the left, 215 pixels. Reset it with 0. Same thing for Y. Positive numbers move him up, and negative numbers move him down. Alright, let's reset him to 0. We can shrink him by entering a smaller number in the size box, or we can enlarge him by adding a larger number. And finally, we can rotate him. We can either type the number in here, or we can rotate him using the dial. We can also flip him left and right, or we can lock him to not rotate at all, so he's always facing in this direction. To the right of this is the backdrops section. Here we can choose what backgrounds will appear in the game. We'll worry about this once we have the game mechanics sorted out. So now we know our way around our workspace, let's start thinking about the game we're going to make. What do we need to make this game? We need a playable sprite, a non-playable sprite that we're going to be catching. We need a timer, a score meter, and some sound effects. Let's start with our playable character. The default sprite is Scratch the Cat. Now, I'm not much a fan of cats, so I'm going to get rid of this one by deleting him, and I'm going to get a nice new sprite from down here. Choose a sprite. Yes. I think I'm going to have this little blue fella here. Just click on him, adds him into our game. Now, let's make him move around. Scratch is started by clicking the green flag. Whenever we click the green flag, our programs begin, and similarly, we press the red flag to stop them. Over here, we have a code block, our first code block, when the green flag is clicked. When the green flag is clicked, I want you to do blum 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 blum, whatever is in these blocks underneath. Now we want our fella to move, so we can move him. With the mouse, that's not very fun. We want to set up so we use the keys to move him. So that's over here, in motion. motion. Let's have him move 10 steps. Move 10 steps. When I click the green flag, move 10. Let's try that. Boom, boom, boom. That's great. So we have movement, but the only problem is we don't have continual movement. We don't have any other movement. Movement only happens a split second we hit the green flag, and then it stops. So we need to introduce something called a forever block. Over in control, we have a forever block. Let's take our move 10 steps and put it in here. So forever, move 10 steps to the right. Let's click on here. Let's run our program. See you, dude. He's gone. Stop our code and let's drag him back by his tail. Ow. That's great. Not very helpful to us. Still, we need it to be at our command. We want it so that when we press up, he goes up, down, left, right, and so on. So we need to introduce something called an if block. Delete blocks you don't want by dumping them over here. Still in our control section, we want an if block. If something, then something happens. So we want this to be, if I press left, the character moves left. So buttons are handled in sensing over here. Okay. Key, space, press. We're not using space, we're going to use the left arrow. We're going to put that in here. If the left arrow is pressed, then we want them to move left. Movement is handled over in motion. We want to change X, because if you remember, X is our horizontal axle. So change X by 10. And remember, 0's here. So if we want to go left, we have to use a negative number. So I'm going to say change X by -10. Great. So our code reads, if we press left, then we change X by -10, which means we go to the left by 10 pixels. So now I'll highlight the difference between when flag clicked and forever. Again, so if I put this immediately here, I press the flag, nothing happens. If I hold down the left key and hit the flag, we have movement, which is no good for us. Because again, when you hit the green flag, it runs this immediately and then stops. If we have our forever block, the forever block constantly cycles. So it never stops running. So it's always going to check if we are pressing the left key. So if we run our code now, every time I press left, we go left. Great. Let's do that 3 more times. Let's take our block out of here and let's duplicate this one. Right click, duplicate. We can stick it down here. Now we've got left arrow. Let's make this one right arrow and remove the minus mark. Great. How easy was that? So let's grab our blocks and chuck them back in the forever. Run our code again. And now we have left and right control. Pretty good. Okay. Let's do that again. Let's take this whole block, right click your mouse, duplicate. So now we've got all 4. We're going to change this to up, change this to down. But of course, X and X are only for horizontal. We want to change these two to Y. So let's get rid of these blocks. Go down here, change Y by 10. Another one down here. And again, because we're going up, we can keep a positive number, but because we're going down, we want a negative number. -10. Drag them all back into our forever block, and we're away. Let's test. Left, right, up, down, left, left, left. Ah, we have a problem here. Our little dude is going off the screen. That's not good for us. There are 2 ways we can fix this problem. We can either use a load of if blocks to dictate the barriers of the screen, or we can use a very handy one down here called if on edge bounce. If on edge bounce. We want to add this to the bottom of our block here. So our code reads, when the green flag is clicked, constantly check if the left, right, up, down arrow are being pressed, and if so, move accordingly. And if you hit the edge, bounce back. Let's have a go. Oh, it works. It keeps us. What's all this flipping business? Oh no. Now we know how to fix this, don't we? If we go back down here to direction, type in 90, and we can lock him. Lock. So no matter what, he's always going to be facing this direction. Let's give it a run now. Great stuff. There we are. He's always facing to the right. Superb. All right. So our playable character now is done. So now we have our playable character sprite done, let's think about our non-playable character. The target, the thing we're going to be catching throughout the game. We're going to need a new sprite. Let's go down here to choose a sprite, and dogs chase balls. Of course they do. Great, so here's our ball, here's our sprite. Now if you remember back to the game, it appeared at random places, random positions. And over in motion, we have the option to go to a random position. Great. So again, we're going to need an events when green flag clicked block. I'm going to click that. Great. And it's appeared at a random position down here. So we can grab our dog now and run over and grab it. That's not very good. That's not what we want to happen. Okay. How can we change this? Well, we need something called collision detection. We need the program to check to see if this is touching this, and if so, do something. Now, there are loads of ways of doing collision detection in other languages, dozens of ways, and all equally complicated. Thankfully, Scratch is really, really simple. Scratch has a simple touching under sensing. So we'll go back to sensing, okay, and touching. So we're thinking about our ball, and what do we want to be testing for? Touching our dog. So touching dog. So again, it's constantly asking a question, which means we're going to need an if block. Put that in there. If the ball is touching a dog, then what should it do? Go to a random position. Click in here. Okay. When the green flag is clicked, if we're touching the dog, then go to a random position. Now, are you already shouting at your screen? Have I forgotten to do something here? And yes, I have. Very important block. We wanted to constantly check if I'm touching. Okay. Now we need to have our if on edge bounce block as well. All right, that's done. Great, let's run it. Green flag. Gotcha. Great. And that's it. So we have the fundamentals of our game set up already. All right, great. But it's not much fun. It's not much of a game. What we need to do now is introduce the score element. So when our playable character touches the non-playable character disappears and reappears at a random spot on the screen. That's great. What we need to do though is to add 1 to your score every time it does that. Now we need to introduce something called a variable. Now go across some blocks called variables over here. You need to create a variable. In here, make a variable. We're going to call ours score. Simple. Now a variable is a little tiny piece of data that your program will keep track of, adding numbers or taking numbers away from it, for example. In Mario, your lives is a variable. Every time you lose a life, it takes 1 off the total amount of lives and reduces the variable by 1. Every time you get a green mushroom, it adds 1 to that variable, so lives goes up by 1. Similarly, time, coin count, these are all variables. We're going to have 2 variables in this game. Our first one is the score one. So now we've created a score, we need to tell it when to change this variable. Change my variable by 1. So where do we want to put this? So when the flag is clicked, change my variable by 1. Well, no, that won't help us because that would give us a score of 1 and then nothing else will happen. Forever, change my variable by 1. Also no, because that just means variable will go to infinity, which also doesn't help us at all. What we need to do is put in here. Conditions met. So if the ball is touching the dog, then we're going to change score by 1. And then go to a random position. All right, let's see what happens. Let's run our code. Green flag. 2, 3, 4, 5, 6, 7. Great, so it works. Lovely, really easy. Let's stop our game there. Let's run it again just to make sure it hasn't gone wrong. Play. Oh wait, hang on a minute. I started my game, stopped my game, and started a new game, and yet score has remained at 12. That's no good. I want it to reset every time. We need something to reset the variable each time we start a new game. So what happens when we click the green flag? That's the very first point, isn't it? So we want to put our set variable immediately after that. Let's go to set my variable. We're going to set score to 0 and put that right at the front. Okay, so when we click the green flag, the score is reset to 0. Let's try it now. Green flag, it's set it to 0. Catch the ball, catch the ball, catch the ball, stop the game, restart the game. Back to 0. Great. That is phenomenally simple, but that's us done. Great. Okay, now let's think about the timer. Things get a bit trickier here. Right, let's start thinking about the timer. Now, this block here only applies to this sprite, which is why we can control the dog but not the ball, for example. To make things tidy, let's do the rest of our code over here. Right, so we need a timer. So that means we've got to create another variable. So let's go back over here to variables. I'm going to call this one timer. We have our new variable called timer. Now let's have a whole new code block to govern our timer here. So back to events, and when the green flag is clicked. Now, unlike our score, which starts at 0 and goes up, we want our timer to start at a number and work its way down. Now, when you're doing the game properly, you'll want that number to be like 30 or 60 for 30 seconds or 60 seconds. Because we're going to be running ours a few times to make sure everything's working, let's set it to quite a low number. So let's go across to variables, and let's take our set my variable to, set timer to, let's have about 8 seconds should do it. Okay, so let's test this out. Green flag, great. Timer's at 8, scores at 0. Let's have a few test runs. Got it, got it, got it, got it, got it. Great stuff. You can see our scores going up, but nothing's happened to our timer because we haven't told it what to do yet. So let's stop our code. All right, so the rule is we want it to wait for 1 second and then reduce this number by 1. So after 1 second, 8 becomes 7. After another second, 7 becomes 6, and so on and so forth. So over in control, we have a very handy wait 1 second box. Okay. Set time to 8, wait a second, and then back to variables. Change timer by -1. Great stuff. Super easy. But this isn't going to work, is it? If I click green flag now, it's going to go 8, 7 and do nothing else. Great. Again, we do our old friend forever. Forever. Wait 1 second, then change timer by -1. All right, let's try this. Okay. Oh, we can see the timer's going down, score's going up. This is great. 3, 2, 1, 0. Oh, -1, -2, -3, -4, -5. This is less than ideal. So we're going to need to introduce a method of stopping at 0. We need to tell the computer that if the timer is 0, then you have to stop code. Now, I don't think we want to stop all code. We just want to stop movement, and I'll explain why in a little bit. But let's go get our if block. If something, something, something. We want to be checking. We want to check two things against each other. We want to check that if the number that equals timer, in our case is -6, we don't want that. We want to check that if this number is the same as 0. So we need an operator. So we're going to think, if our time is less than 1, meaning if our time is 0, then we're going to stop. So we want a lesser than symbol. That's over here. We drag this across. If something is less than 50, then do something. Now we don't want that. We want it to be less than 1. Okay. If it's less than 1, do something. So let's grab our timer block from down here in variables and put it all together over here. If our timer variable is less than 1, then stop. Back to control. And stop. Stop all. Now again, we don't want to stop all. Because if we stop all, that means everything in the program will come to a screeching halt. Now we don't want that, because maybe we want there to be a little game over screen, or a little message, or to print your high score. So all we're going to do is stop the other scripts in the sprite, which means we can no longer move and our score won't change, which doesn't matter because we can't move anyway. Great. So let's put all this together. So our code reads, when the green flag is clicked, the timer is set to 8, and forever we're going to wait for 1 second, take a number off timer, and if the timer gets to -1, meaning if it gets to 0, then stop the other scripts in this sprite. Alright, let's try this out. It's gone up to 8, score's gone to 0, 6, 5, 4, 3, 2, 1, 0, and I can't move. But oh no, what's happened here? Our timer is still counting down. How can we get around this? How can we lock? How can we set our variable to something? Very simply. Let's stop our code here. Let's go back to variables and let's set our variable to 0. In our case, let's set timer to 0. Let's put that in here. All right, so now green flag's clicked, timer set to 8, forever, wait a second, take 1 off. If it gets to less than 1, meaning 0, we're going to set our timer to 0, and we're going to stop the other scripts in this sprite. All right, let's have a final check. 8, 7, 6, 5, 4, 3, 2, 1, 0. Brilliant. So we're pretty much done. Some things I don't like about this, though, I don't know the fact that it just kind of stops. Maybe someone who played the game, who wasn't you, thought, oh no, the game's crashed, maybe there's something wrong with my PC. Let's have a little message to the player to say that you're done now, game over. Now we can do that over in looks. Go across to looks, and you can say something. You can say it for a duration or say and leave it there. You can either say or you can think things. Now say makes a little speech bubble appear on the sprite, think makes a little thought bubble appear. We're going to use a speech bubble. We're going to put that over here. Now it's very important we put that in here. If we put that over here, for example, it would say hello, but as soon as the timer runs out, it's going to go 0, which is the opposite of what we want to happen. We want the timer to get to 0, we want him to say hello, and we want him to stop movement. Okay? Let's change it. Not to hello. Game over. Superb. Say game over. All right. Check. 7, 6, 5, 4, 3, 2, 1, 0. Game over. Brilliant. That just leaves one extra thing we've got to do. We need to start thinking about adding sounds. Alright, so we need to add a sound effect to our game. Now, the rule is when we touch the ball, it plays a sound, which means we have to go back to our ball sprite and our collision detection code. Sounds are controlled over here. Let's have sound start sound. Now, pop, that doesn't sound very good. We're not popping the ball. We're kind of giving it a bite. Now, from my experience, dogs, when they have a squeaky toy like this, it goes squeak. So let's go find a new sound. Let's add a new sound. I'm not going to go search through these individually. Let's type squeak. Ah, look at this squeaky toy. That is perfect. Let's add that. It's a bit loud. Let's make it a bit quieter. That's great. Okay, so we've got our sound. Go back to our code. Start sound squeaky toy. Add that to our code. All right, let's have a go. That's not too annoying. I think I'll do quite nicely. Not bad, 15 in 8 seconds. Good stuff. So we're done. We've met our original criteria. We've got a playable sprite, a non-playable sprite, a timer, a scoreboard, and a sound effect. Let's go above. Let's go one extra step. Let's have some music playing while we're going through the game. We can control music through the dog sprite. Because again, when this timer runs out, it's going to stop all the scripts. So if we put our music script here, for example, the music will only play while the game is running. Let's just get a new when flag clicked. We want it to play constantly, so we need a forever block. Forever. And we want to say sound. Play sound until done. Now again, we don't want it to play a dog sound. That's going to drive us crazy. Let's have a whole new sound. Let's go back to sounds tab. Let's add a sound. Now we want to add something called a loop. A loop is a short piece of music that you can play end to end to end to end. So it sounds like one long piece of music. Let's have a look at some examples here. We've got this. It's quite good. Yeah, it's not quite in the mood of my game. Oh, definitely not. I think I'm going to go with... That's quite fun. It's quite lively. Let's have a go with that. That's quite good. But it's very, very loud. Let's... Nice background level. That'll do nicely. Okay, that's now in our library. Go back to code. And we're going to play sound guitar chords until done. All right. So, let's have a test. Green flag, go. Only 11. I'm losing my touch. Here we are. We're pretty much done now. We have our sound effects. We have some music going in the background. Of course, you can have whatever music you want. Feel free, go nuts. Let's do one final thing. That white backdrop is fairly tedious. Let's put a fancy backdrop in there. Let's go down here to choose a backdrop. And let's have, wetlands quite good. I think let's stick with that one. That's quite interesting. All right, and seeing as we're done, let's get rid of this 8 seconds. Let's have a proper time limit. Let's have 30 seconds in here. Okay, so let's do it for real now. Let's go make our window full screen by clicking here. Bang. Green flag, 30 seconds starting now. I'm pretty good at this. I've had a bit of practice. Well, that's unfair. That's quite a big stretch between the two. Oh, I was lucky. So if they're close together, you get a couple of points in one there. Nice. All right, can you beat my score? Keep an eye on this, people. You've got 30 seconds to beat a grand total of 39, 41, 42, 42. You got to beat 42 in 30 seconds. And then we got a little game over message. Great. So that's us just about done. Well, for today, for you, why don't you go on? Why don't you expand this game? Maybe make it a bit more interesting. Maybe you'd like to change the size of your dog. Maybe you think the dog is too big, and I kind of agree. Maybe if you use the scale tool down here, you can change the size of your dog, make it smaller. But then, if you've got a small dog moving at a slow speed like we have now, that game's going to be unbearable. So if you do change this variable, be sure to change other things, like change the speed at which you move at. What other things could you do? Maybe you could make more than one ball appear. Maybe you could wait 20 seconds and then a second ball appears. And the final 10 seconds is you chasing 2 balls. Great. Maybe you could have it so the ball is constantly moving. It doesn't just teleport. You can chase it around and really build up your score doing that. And if this is too boring, you can add your own sprites by uploading your own pictures. Same for backdrops. Upload a photo. And you can even make your own sounds in the sound tab. Thank you very much for watching. I hope you've enjoyed it. My email is on the screen right now. I'd love to hear from you about your projects in Scratch or any questions you might have. And if you're ever in the Centre for Computing History, give me a shout and I'll challenge you to a 30-second game of Scratch Catch. Beat me and you'll be a champion. Don't forget to hit like, subscribe and the notification bell to find out when our new content goes live. Also, we now have a Patreon where for less than a coffee, you can get early access to all our videos and get behind the scenes info from the Centre for Computing History. This is Dan, and I'll catch you in the next video.